Good morning, everyone, and welcome back to Hamcation Special Edition 2021. Welcome to the AMSAT CubeSat simulator. Will be presented by Alan Johnson, KU2Y. We will be accepting questions through the session. If you have a question, turn around, just post it out in the Q&A section of it, and we will turn around and we'll try to field those during the webinar, and we'll also take questions at the end of the webinar, approximately 10:45. We will have to turn around and wrap up the webinar at about 10:53 for the follow-on presentations to allow those to continue. So, and then as the webinar is closed, Alan will be sharing an email address in case there's additional questions that would like to be asked at that time. So this webinar is also being live streamed on YouTube and is being recording for later viewing. You can find the information to access the videos at www.hamcation.com under forums. And just so that you know, your camera does not need to be on and your microphone is initially muted. If we need discussion Q&As during that, I can unmute your, give you the opportunity to unmute your microphone at that time. Okay, and with that, I will turn it over to Alan, and we'll go ahead and start, allow him to start his presentation.
Okay, thanks, Mike. Good morning, everybody. I'm Alan Johnson, KU2Y. I'm the VP of Educational Relations at AMSAT, the Radio Amateur Satellite Corporation. And I'm also on the faculty of Villanova University in the Electrical and Computer Engineering Department. So today I'm presenting on the AMSAT CubeSat simulator, the CubeSat sim, and I'm presenting on behalf of the other project members, including Pat Kilroy, N8PK, Jim McLaughlin, KI6ZUM, and David White, WD6DRI. This project wouldn't be where it is today without all of their support. So a little bit about myself. I've been a ham for many years. I first got active in my teenage years, and I got active with amateur radio satellites. I actually made my first satellite contacts using Oscar 8. So that kind of dates me as to when I was active back then. Recently, I've become active again, and I enjoy working the satellites. And I really like the CubeSat simulator because it brings my love of ham radio and my love of teaching and sharing radio and technology with students. So let's go ahead and get started. Let's see if I can advance my slides here. Interesting. There we go. That's better. So I'm running a live web SDR. So you can click on this link and you should be able to join my my web SDR. I'll send the link here also to the chat room, so you can click on it there. And let me just show it here for a second. So here it is. Yeah, it looks like some of you are joining. Once we hit 20, you may get kicked out, but we'll see how we go. So right now it's just tuned to NOAA weather radio. So you might be hearing about the weather here in Philadelphia. I'm going to switch it to the 2-meter band here, just because it's a little more interesting. And in particular, if you click on this packet here, it will actually automatically decode APRS packets as they come in. So, all right. So a little bit about AMSAT, the Radio Amateur Satellite Corporation. Robert is going to be presenting a little later on it, so you'll hear a lot more about it. But it's basically a not-for-profit that was formed for keeping amateur radio in space, for launching satellites, and promoting science and space education. My involvement in AMSAT is the educational outreach mission, which takes a lot of forms. There's a group called the AMSAT Ambassadors who give presentations and demos of satellite communications. So if you're interested in having that in your club or your event, then you can get in touch with them. AMSAT is also a primary sponsor of ARIS, Amateur Radio on the International Space Station, and they do great work with organizing school contacts between astronauts on the ISS and school groups, and they're even managing to keep doing that now during these virtual schooling days. So great job by them. Also, AMSAT does a lot of partnerships with universities in terms of flying experiments and the like. And then also what I'm talking about today, which is the CubeSat Sim program. So most of you probably know what a CubeSat is, but just in case you don't, a CubeSat is a nano satellite, and it can be as small as 10 centimeters cubed, but they can also be stacked into bigger increments, and they're primarily for educational use. They're designed to be low cost, easy to build, easy to launch because they're standardized. You stack them all up and you can launch a whole bunch of them at once. And they just go into typically low Earth orbit. So, around the height of the International Space Station, a few hundred kilometers. And as such, they do not contribute to space junk because they deorbit after a couple of years or a few months. And they're just really good for education. And of course, AMSAT has launched a series of CubeSats, the Fox series of CubeSats with transponders on them as well. So why a CubeSat simulator? Why is AMSAT a group that builds real satellites and puts them on orbit? Why would we care about a CubeSat simulator? Well, it's part of our educational outreach, and it's to help explain how satellites work. And there's really nothing like having a satellite in your hand when you're presenting, or if you're a teacher, having a satellite on your desk to help explain things. And it's great for demos. It's great for classrooms. Also, we think there's a role where it can actually help CubeSat developers be successful. I'll talk about that in a minute. And it's also a potential outreach to link the amateur radio community and the maker community, right? People who love to 3D print things and solder projects and hack code. This is a way of perhaps introducing them to amateur radio as a developer. Okay, so what is the AMSAT CubeSat Sim? There's a picture of it there. This one has the tape measure dipole antenna. Of course, tape measure antennas are popular with CubeSats because they're cheap and easy to deploy. But the CubeSat Sim, it's based on a Raspberry Pi Zero W, so that's the processor. But it's a functional, one-to-one model of a real 1U CubeSat. And it's designed to operate as if it's in low Earth orbit as much as possible. It runs on rechargeable batteries and has working solar panels. The solar panels on here these are like $2 1-watt solar panels that we buy from China. So that keeps the cost down. Real CubeSats have, of course, much more powerful and expensive solar panels, but these work pretty well. And of course, as radio enthusiasts, the thing we like about it is that it transmits real housekeeping telemetry on the 70 centimeter ham band, and it does it on a bunch of different modes and modulations, so you can listen to them and decode them with software. And also, it also transmits slow scan TV, which is kind of fun. And if you take it and place it on a rotating turntable in front of a lamp, as we're about to do, or put it in the sun, it simulates a real satellite spinning in space, and it generates some pretty interesting data that we'll be looking at here. So I'm going to try to make this session pretty interactive. There's some slides, but we're going to spend a lot of time just playing around with the simulator that I have on my desk here. All right, so just back to that issue of helping CubeSat developers be more productive and more successful. Unfortunately, a lot of CubeSats fail. They just become flying bricks. They get deployed and we never hear from them. And there's various reasons for that. But one idea is that many CubeSat developers, especially first-time educational institutions, they jump straight to building their flight model, and that's what they do. And they make mistakes, and they don't understand the whole the whole system, right? Because it's really really a whole system. Oh, will my slides be available? Yes, my slides are actually available already. Let me share the link. Thank you for the reminder, Perry. Perry, by the way, is one of the founders of AMSAT and first president. Okay, so that link should work for downloading the slides. So one idea is to try to encourage CubeSat teams, especially first-time teams, to take a step-by-step approach, which we call the one small step at a time. Apologies to Neil Armstrong. And the idea is that you do things gradually and hopefully have more success. So we might start at the crawling stage. And the first thing that we recommend CubeSat developers do is get their ham radio license, connect with the local ham radio community, find who's got ground stations and who has experience in this, because that sort of mentorship can be extremely helpful. Then maybe you're ready to walk, and maybe the first thing your team can do is build a CubeSat simulator. It only costs a few $100s. It only takes a few hours, and then you've got something in your hand. You've accomplished something, and also you can get exposed to the whole aspect of a CubeSat mission, from building it to testing it to getting telemetry and learning about your CubeSat. Then maybe you're ready to run, and that's when you might build your engineering model and your test unit. And then finally, you're ready to fly with your flight model. And we're actually seeing some CubeSat teams do this and take this approach. So I'm really looking forward to hearing about their successes in the future. So there's two versions of the AMSAT CubeSat Sim. There's the full CubeSat simulator and also the CubeSat Sim Lite. The full CubeSat Sim has 3 circuit boards, and we'll look at those in a bit. It costs about $200 in parts to build, and it requires basic soldering and setting up a Raspberry Pi. Might take 10 hours, maybe a bit longer. The CubeSat Sim Lite, on the other hand, is just a single board. It just plugs into any Raspberry Pi, and it skips the solar panels and the batteries and the sensors, but it generates real telemetry. It transmits slow scan TV, and it also simulates telemetry too, which is kind of cool. So the CubeSat Sim Lite, you just plug in to any Pi. The CubeSat Sim, you stack the 3 boards, and then you plug a Raspberry Pi Zero into the bottom of it, and you're ready to go. And both of them transmit real telemetry. And if you have the CubeSat Sim, it also charges the batteries, and you can see the solar panel currents and voltages and that kind of thing. You can also take the CubeSat Sim Lite and just put it in a 3D frame and maybe add a USB power pack, and you've got something that looks like a CubeSat you can pass around and do things with. Okay, so I promised you we would do some demos here, so let's go ahead and get to those. By the way, these cool AMSAT remove before flight tags are available on the AMSAT store for a donation. So if you're interested in those. All right, so I'm going to check in on our WebSDR here. Okay, so looks like we're maxed out at 20 clients here. So maybe later others can disconnect and let others join in here. Decoding a lot of APRS signals in my neighborhood here. Let's just have a, oops, that was interesting. Let's have a glance at if you click on this little coordinate spot here, it actually pulls up a map. And you can see the various signals here mapped here. So this is pretty cool software. See my location here in Center City, Philadelphia, with all the different signals there. Okay, so I'm going to switch back. Second. Okay, so I'm going to switch modes here, and I'm going to switch to the 770 centimeter ham band, and there we go. And if you click on this CubeSat Sim bookmark here, that will actually tune it and get it ready for the CubeSat simulator, since we're going to start it up in APRS mode here. All right, so I'm going to stop sharing, and I'm going to switch to my desktop camera here, see how that works. Okay, that seems to be working. So here is my CubeSat simulator. Right now I'm charging it with a USB cord. You can see the red light there. So I'm going to disconnect that since we don't need that anymore. But you can see the solar panels. This one has a little rubber duck antenna instead of the tape measure antenna, but it's got solar panels on all sides there. All right, so we're ready to launch here. And just like a real CubeSat, the way you launch it is you take out the remove before flight. Okay, so we'll wait for it to go through its power-up sequence. I'll just point out here, this is a Raspberry Pi running software known as the Aris Radio Pi. You can actually see the Raspberry Pi here. It's actually, there it is on the back. But it's a really nice little touch screen that I like for it. And it actually runs the same software that you're using right now. You're actually connecting to an Ubuntu server. Okay, the simulator. All right, did you hear that? That CWID? So it just came alive, gave a CWID, and just gave a CWID, and now it's sending APRS packets, and you can see it here on the WebSDR. Okay. So let's have a look here. Share my screen again. So here we are. So if you clicked on this, unmute it here so we can hear. So if you clicked on this CubeSat sim and you're tuned to it, then you should be getting decodes here. You can see it's using the AMSAT call sign, W3ZM. And the format here begins with hi, hi, and then a series of numbers. This is the old Oscar 7 format, Oscar 7 being my favorite AMSAT satellite with all the different data. This can be decoded if you paste this into a spreadsheet to get all the voltages and currents. And then also at the end here is some sensor data, and I'm going to talk about that. There's a BME 280 sensor and an MPU 6050 sensor as well. Okay. All right. So now let's switch modes here. So I'm going to stop sharing. This CubeSat sim does multiple telemetry modes here. So I'm going to switch it, and I do it by pressing on this button and holding it. And I'm going to switch to mode 2, which is 2 blinks on this green LED. One, 2.
Excuse me, Alan. Do you want to go full screen on your camera?
I want to go full.
We've got a split screen out there right now.
What else am I showing?
Me.
Oh, I think if you disable your camera, that will fix it.
Very good.
Okay. All right, so now we've switched modes, and if you're watching the WebSDR, you'll see the signal has changed. It's a continuous signal. It's basically a low frequency rumble. This is the data under voice that the Fox satellites do, and you can see the blue LED flashing here to indicate that it is transmitting. So I'm going to switch here. Switch to this one here. Okay, so this is what the data under voice looks like, and it's just kind of a low rumbling sound here. Um, but I'm going to switch modes here in my Pi, and I'm going to run Fox2Lem. That is the AMSAT software that is used to decode uh, the telemetry from our satellites on orbit. The CubeSat simulator simulates that. So here you can see it. See the signal here, 434 megahertz. We have a nice open eye diagram, and here's the digital data. And if I click on you see these tabs here for the various CubeSats that AMSAT has launched, AO 91, 92, 95. If you click on the CubeSat Sim one, you can see there's real data being generated here. So let's see. For instance, we can look and see that the battery voltage is very healthy, 3.93 volts, and we can see that the current is 272 milliamps. Over here, the PSU, the power supply. So the Pi is being given a nice 5-volt source and 186 milliamps of current there. In addition, we can see data on the individual solar panels, plus X, plus Y, plus Z, basically the different axes. And right now, the voltages are kind of low. The plus X panel is a 4 volts because that's the one that's facing the window here. But let's go ahead and really launch the CubeSat Sim. Once it's in space, it's going to be spinning. So I'm going to turn on my turntable here, and let's also put it into out of eclipse and into the sun. So I just have a LED lamp here. It's only a 3-watt lamp, but it is actually enough to activate the solar panels. So now, as we look here, we should see the voltages start to go up. Yeah, here we go. The plus X panel was at 4 volts there. And we also should start seeing some currents. There'll be small currents. Here we go, 6 milliamps. So again, this tiny little LED is it's producing a small amount. We can also graph these. So if I double click on the voltage here, I can pull up this graph, and you can see in real time here how the different panel voltages, how the voltage peaks as it faces the lamp. And we can do the same thing for the current here. Looks like my plus, I need to add my plus Z panel current. By the way, this Fox2Lem software is just terrific software, written by Chris Thompson, and it's great for analyzing satellite telemetry in real time. And it's written in Java, so it runs across all platforms. So here you can see the peaks. We're only getting 6 to 10 milliamps, but it's enough to see. And you can basically, by looking at the period of this, you can tell. John asks, is the source code for Fox2Lem available? Yes, it's all on GitHub. If you go to Chris's site, I think his call sign is AC2CZ, and he has a website with a link to the GitHub for it. Yep. Okay, so we are working here. Also here, look under experiments. There is it says STEM payload OK. So I'm going to show you the STEM payload board, which is one of the exciting new things we've added to the CubeSat simulator. And it includes sensors. And right now it's reporting that the temperature in my room right now is 27.2 degrees Celsius. The pressure is 1008 millibars. The estimated altitude is 41 meters, and the relative humidity is a pretty dry 16%. So this is real-time data that's getting transmitted by the STEM payload board. Okay, so let's do one more fun thing here. So I'm going to stop here, and I'm going to switch to, so here is the, oops, that was the WebSDR. Here is the WebSDR. So if you're looking at this, and you can clearly see here with it magnified, see how there's two peaks, right? This is the frequency shift keying, the ones and the zeros, basically going back and forth between the two. Now, I'm going to switch modes one more time on the CubeSat sim, and I'm going to put it into slow scan TV mode, which is mode 4. Okay, I just put it into mode 4 there, and I'm going to, and now we get the ID, and now we should hear slow scan TV. There we go. Should recognize that sound. So on my Pi here, which I think you can see, I'm going to run the slow scan TV decoding, and we should be able to decode that. I'm also going to run my little slow scan TV app on my phone here and see how that works. Okay, so that's working. And I'm going to unmute my WebSDR here. And let's see if we can get it decoded. Getting anything on my, let's say this is what I'm getting on my app. Not very good. However, this way down here. But you can see on the Pi, we're getting quite a decent decode. With that using QSS TV. All right, so I'm just going to show one more thing here, and I'm going to shut down the CubeSat simulator here for the moment. I'm going to shut it down, and I'm going to turn on my CubeSat Sim Lite. And I'm going to get rid of that mute here. Oh, missed a couple of questions here. I'll share a link later on the GitHub where you can get information on the boards. What else here? Oh, the URL for the slides, I can repost that again here. Here's the slides. So yeah, there's a list in the slides. The question is, are the boards for sale? I'm going to talk about kits and the like in a little bit. Eugene saying you can't push the button in space. This is true, but this is a satellite for your desk, and it has the advantage that once you build it, it's not going to eventually burn up in re-entry. So I say a simulator is better than a real satellite. Okay, All right, back to things here. Oh, okay. Looks like somebody switched modes here. It's actually a shared resource, so when uh, when, uh, when one of you switches modes, we all switch modes here. So okay, so right now I'm going to just stop sharing for the minute here. So I have my CubeSat simulator light here. So it's just this small board with an antenna, and it's plugged into, this is actually a Pi 4, but it plugs into any Pi. And I'm going to start it transmitting here, and I'm going to start it up in mode 3 here. So, okay, that should start. Notice it also has a little camera too, a little Pi cam. Okay, so that is starting to transmit. So let's go back to, yeah, that's okay, Louis. That's the fun of live demos. You never know what's going to happen. Okay, so we are transmitting here. Now this is a continuous signal, but it's a different signal. Let's have a little listen to it. A bit here. So this is actually a binary phase shift keying, BPSK, 1200 bit per second telemetry. This is the telemetry that was used by HuskySat and also Fox 1E, and also future missions as well. Let's see if that starts transmitting. So we shouldn't be listening to this in FM. We should actually demodulate it using USB. Yes, that's the lovely sound of BPSK. I'm going to mute that because that is pretty annoying. We can go back to Fox Telem here on my Pi, and we can again decode it using Fox Telem. And now, because this is the simulator light, we're just going to get simulated telemetry. Okay, so there's our signal, and you notice that we're no longer decoding it here because we're in FSK DUV mode. So I'm going to hit stop. I'm going to click on BPSK Fox Husky and now say start. There we go. Now we're decoding. When this phasor diagram is basically a straight line, that indicates that it is decoding. Decent eye diagram and something that looks like digital data. So let's have a look here. This time I click on the CubeSat Sim BPSK because I'm actually simulating a different satellite here. And let's see what we have here. Make sure our data is updating. We've got 5 packets so far here. Yeah, that's updating. Now, if you notice, we're getting some much higher currents here. Right here, it's showing 156 milliamps of current. Now, of course, this is purely simulated. These are just numbers, but they're realistic looking numbers based on some algorithms with some noise and some randomness too. So yeah, so here we are. And of course, right now it's showing stem payload fail because there's nothing plugged in. But if I did actually plug it in, it would work. Okay. All right. So I think I'm just going to leave this simulator here in slow scan TV mode. So, and it can actually transmit pictures from the camera, which is kind of fun. But I just want to talk a little bit about the boards and show them, and then we'll finish up with the last few slides. All right, and maybe I'll mute that so that so that we don't have to listen to it. Okay, very good. So so these are the blank boards. Right now, the Gerber files for them are available on GitHub, so you could make your own. Eventually, we hope to have them available for a donation from AMSAT. So here is the Pi Zero. This is the brains of it. This is the smallest Raspberry Pi, just $10. Here is the main board itself, built up. You see the SMA connector on the top there. These purple boards are the sensors for the current and the voltage. This is the battery charging board, and this one is the 5-volt regulator. Here is the battery board. This is just AAA batteries, nickel metal hydride, rechargeable. But AA's are also good, last longer. And then this is the STEM payload board that I'm excited about with the SparkFun Pro Micro. You can also plug an STM32 as well. Okay, so I'm gonna get back to finish up the slides, and then we'll still have time for more questions at the end. Okay, so again, the demo is the WebSDR is still running, hopefully, so you can monitor it there. Actually, let's just check in on it, make sure it is still running. Looks like it is still running. Yep. Now, to decode the slow scan TV, we want to be an FM and nice and wide there. So, yep. So in theory, that will decode. Looks like there's 7 spaces on the SDR if you want to try it out. If you got a busy before, it's available now. So I'll just say one thing about the board itself. There's no transmitter board. There's no real RF circuitry on the simulator, and that's because we use the RPi TX library, which uses the clock pin on the Raspberry Pi to basically generate RF signals, which is really clever and of course very inexpensive. It only generates 1 milliwatt, but that's all we need to operate in a room. However, because you're generating RF with a digital pin, it's a square wave, you get all kinds of spurs and harmonics. So we always use a bandpass filter. So I just wanted to show you here, on the left here, this is before filtering. So you see the fundamental here is this first peak. The first harmonic here is almost as high. Second harmonic is high, and you have all these spurs, just a huge amount of spurs, just really horrible signal. But after simple bandpass filtering, you get something that's reasonable. It's not perfect. The harmonics are about 30 dB down, which is okay. Question is, why not a battery shield? Oh, you mean like a specific Raspberry Pi battery? Yeah, I actually, the first version used one, but I didn't have control over the charging and the efficiency, and that's why we use our own charging circuit for it. Okay, so here is the STEM payload board that I mentioned, showing the Pro Micro. This is the gyro sensor. This is the pressure, temperature, humidity sensor, and it also has space here for your for building your own things. Like I've added a GPS sensor onto one of mine, and it's possible that board will get flown on a balloon at some point. But anyway, I wanted to thank Jim and David. They designed this STEM payload board actually before they joined the CubeSat Sim project, and it's a great addition to it. So we looked at the simulated telemetry with the CubeSat Sim. So this is just some examples of that. And you can see here how I simulate eclipse and illumination. So during eclipse, you got currents from the solar panels. You get a negative battery current indicating charging. And then when you go into eclipse, the solar panel power goes away, and instead you run on positive battery. And you can also see the battery charging and discharging. So it's kind of fun. And each time you reset it, it generates new parameters and starts at a different point in time. So it's kind of like what simulated world are you in? All right, so hopefully I've gotten you interested in the CubeSat Sim. Question, how many people are watching? I believe there are 179 participants and possibly more on YouTube as well. So hopefully I've gotten you interested. And your two options, whoops, are to build one or borrow one. And if you go to cubesatsim.org/wiki, you can see all the instructions and all the code. Um, and you can print your own 3D parts, or you can order a print online. On the other hand, if you don't have the time or interest, you can borrow one. We have a number of simulators. Um, and if you just contact me and you have a specific plan for an event or a classroom, I can ship you a simulator and in a ruggedized case, as it shows there, with all the parts, and you can demo it for the students. It's really a lot of fun. Or bring it to a maker fair or show it at your next club meeting. So contact me for information about that. Um, I mentioned I was going to talk about kits. We had planned kits for 2020, but 2020 happened. Um, Also, the hardware redesign that we've been working on took longer, and we're about to release uh, the final sort of release one of the boards. We've been calling them betas up until now, but we're getting really close. We're really happy with the way that has gone. Also, getting parts in China and shipping things is also tricky these days. But we do hope to have CubeSat Sim boards available at the AMSAT store sometime this year. And we're also looking at getting the CubeSat Sim board, the tiny little one, assembled and having those made available too. So keep posted. Keep see how things go with that. I'm not making any promises or dates for that. So you do need a ground station to go along with your CubeSat Sim. I haven't shown it, but you can always use, you can install software on your laptop, SDR Sharp. You might need VB cable or something. You can run Foxtel-M, MMSSTV. But I really like the Raspberry Pi ground stations, and in particular the Aris Radio Pi. So I've shown that a few times on my desk here. But basically, if you follow the link down the bottom here, it's basically a Raspberry Pi image that you burn onto a micro SD card, and you plug it into your Pi along with the RTL SDR, which I don't know that I actually showed. It was on my desk here, but this is the SDR. This is a $20 dongle that acts like a fantastic little radio. Um, and you plug that into your Pi, and it has all this software pre-installed and pre-configured. So that can be a lot of fun for that. So again, it'd be great if you can participate, if you are interested. Build one, show it off to your club, take it into a school, show it to a teacher, take it to a maker space or a hacker space, or some other event as well. And also, share things on social media, spread the word. We have a CubeSat Sim account with the CubeSat Sim hashtag, so you can follow that. So again, thank you for your time this Sunday morning. If you go to cubesatsim.org, there's lots of information. And also, I would recommend, there's lots of detail in two of our recent papers, the guide to the AMSAT CubeSat Sim and also the activities with Foxtel-M. These are both published in the AMSAT journal, which if you're an AMSAT member, you get electronically every couple of months. But you can also download these PDFs here using these links. So there's lots of information there. Also, something to watch out for, a new AMSAT youth initiative known as CubeSat. So keep your eyes out for that. And finally, just need to acknowledge the folks that have made this work possible, including Mark Spencer, who built the first CubeSat simulator and is basically the inspiration for this. All of our beta builders that build and test and give feedback, and also all the open source hardware and software that we use in this CubeSat simulator. And finally, I'd like to thank the AMSAT board of directors and the members for their support, because they've provided, all this hardware you see here is all supported by them. Okay, so I guess we can pause here and and do some Q&A.
Yes, Alan, we've had one question come in through the Q&A. It's does the Pi software work with a RSD, I'm sorry, RSP Duo for the SDR receiver?
Yeah. So the RSP Duo will certainly work as an SDR. Also, just an FM radio will work for most modes too. Um, the the Pi software does not currently have the AirSpy drivers installed. So if you wanted to use the Pi image, you would just need to go to their website and install their drivers. But yeah, it should work just fine. And then you just need Fox to Lem or whatever software you need. The web SDR software that I'm using is actually called OpenWebRx, and it's a fantastic project to make an SDR accessible to people even remotely, as you've been doing today. So.
Okay, Alan, it looks like you've addressed all the questions so far. There's a lot of great compliments coming in for your presentation. It looks like it's been well accepted, and I think you've motivated a lot of people to get into the CubeSat STEM activities. So hats off to you for a great presentation on that.
Okay.
And thrilled
Thank
to
you.
have you as part of the Hamcation Special Edition 2021. Much appreciated that you took the time and put this form together for us. So very good. So
Okay. Thank
let's
you.
see. Oh, we got one more question that came in. We got a couple minutes here. So came
Oh,
in from Richard.
yeah, what type of antennas do I recommend for receiving sats in orbit? Um, I recommend the Arrow antenna, right? It's 70 centimeter and 2 meter Yagi. Also, building tape measure antennas is so much fun. If you just build the 2 meter version of it, you can pick up a lot of CubeSats. You can also build the 70 centimeter, go outside, wave it around in the air when your tracking software says it's there. That's what I would recommend. Obviously, if you're building a real station, then something like the M2 LEO pack and the like, something that's some antennas that have gain and circularly polarized. Oh, links to the papers on PDF not there. Let's see. Should be. If you go to CubeSatSim.org and then go to papers, that link should bring up the papers.
Okay. And I think one other question buried in there a little bit was if you have any idea how many CubeSat sims are out there.
Oh, how many CubeSat sims? That's a good question. I would estimate over a dozen have been built over the 3 years that we've been doing it, and there's probably more too. People probably build them and don't let me know about it. And we're hoping that with having the boards available and the like, and more publicity will result in more of them getting built.
Okay. I think we've fielded the questions so far. And as you'd mentioned, if there's any additional questions, they can reach out to you with those. And just to encourage everybody to explore the CubeSat part of amateur radio and have some fun with it. So, well, Alan, I think we've addressed all the questions. I don't know if you have any other closing statements you'd like to make.
No, thank you, Mike, and thank you everybody for their time, and make sure you check out the AMSAT presentations after lunch today. I think they start at 1, so you'll hear lots of good stuff there.
Okay, fantastic. Well, we'll wrap this up, and hope everyone has a great day. And there's a few more forums today, so you can check those out at hamcation.com under the forums page, and check out a couple more presentations or forums that will be provided today. Thank you very much, Alan.
Yeah, you're welcome.
Okay. I will go ahead and close the YouTube stream at